Alright, today we're doing an optimization problem calculus. The situation. A man needs help with building a fence to form a backyard for his house without any side yard. Knowing that you have calculus experience, he hopes that you can help find the solution. The man says he needs a yard built with the largest amount of area possible, but he only has 2,400 feet of fencing to do it with. What dimensions should he use to build a fence for a backyard with the maximum area possible? So first, to set up this problem, you might want to start with some sort of drawing of what it may look like. So notice how it's a backyard, he does not have side yard. So one of these sides will in fact be his house, which we'll draw off a dashed line to represent it here. So this is going to be his house, the back of his house. We'll label these two sides X's and this last largest side Y. Okay, so now to solve these equations, you first need to find two equations, in fact, to solve these. So your first equation here is going to be your maximize equation. This is your equation for the area, which is going to be the area equals X times Y. Let's draw this here, represent it. Now you need your constraint. Your constraint is going to be 2x plus y. No, it's 2x because you have two x's, and y equals your 2,400 feet of fencing that you have available to you. Okay, now your first step of this equation is, since you're using substitution, you'll have to solve one of these for y. Now you need to choose the one that you are not maximizing, so this will be this bottom one right here. So in order to do this, you just solve for y, so you can just subtract a 2x from each side, and you end up with y equals 2,400 feet of fencing minus your 2x. So now your next step is you need to substitute this into your area problem, which will be pretty simple. You just do a equals x, and make sure you use parentheses so you can distribute the x, times 2,400 minus 2x, which you replaced instead of your y. Now you can distribute the x to simplify. And there's your starter equation. So now to solve these equations, you need to take the derivative of your maximized equation. Now to take the derivative, you can do dA over dx, since it's in terms of x, will equal 2,400. The x is now gone since you are taking the derivative, minus, bring the 2 down and multiply, and then minus 1 from your exponent, so minus 4x. Now you just have to set this equation equal to 0 and solve for it. So you get 4x equals 2,400, and your x will indeed equal 600 feet. So now you know that you need 600 feet of fencing for this man's backyard. Now to solve for y, all you have to do is go plug this back in to one of your original equations. So you have 2 times your 600 feet of fencing plus y equals the 2,400 feet of overall fencing. So now this simplifies to 1,200 plus y equals 2,400. You subtract your 1,200 from both sides of the equation, and you end up with y equals 1,200 feet. So now you have found this man's dimensions for the backyard, which is in fact x equaling 600 feet of fencing on two sides, and your third and longest side is going to be 1,200 feet long. And that's how you solve optimization problems.